This panel, and we will begin with Alexandra Chouldechova, and she's at the Heinz School at Carnegie Mellon.
Thank you, everyone, and thank you so much to the organizers for inviting me to speak here. I'll start by saying that I'm a statistician by training, but the work that I'm presenting here is an entirely qualitative analysis. There was no randomized sampling or anything along those lines. On the other hand, I hope that this presentation is responsive to at least one of the comments that was raised during the strategizing session, which is this question around design. So how do we design better systems? What sort of information can we collect? How can we do better? How can we better frame the sorts of technical problems that, as Cynthia articulated, we in the more theoretical community might be able to address? So this research is a collaboration between Rima, who's a health economist in New Zealand, myself, a statistician at Carnegie Mellon in Pittsburgh in Pennsylvania, Emily Putnam-Hornstein, who's a social work researcher, and a team of participatory designers out of New Zealand. So the primary motivation for our work is that algorithmic systems, whether they're algorithm-assisted or fully automated systems, are increasingly being adopted by governments seeking to improve their processes and the outcomes for the citizens who they are supposed to assist and support. However, we understand now, either through media coverage or by being in this room to begin with, that a lot of these systems are somehow risking perpetuating harm and discrimination and affecting negative outcomes, all while operating outside of traditional oversight and accountability mechanisms. And what we hope to do with this study is try to understand what does kind of accountability and what does transparency and what does fairness look like if you talk to affected communities. So these aren't necessarily the people who are sitting in the room with you as you are thinking about, well, here's a tool that we're building, are you going to purchase it? These are the people who are most likely to be using these tools, or the people who are most likely to have these tools used on them. And the three central questions that our study sought to answer is as follows. So first, we were interested in how do the people who are most likely to be subject to or affected by algorithmic decision making, in our case, focus on the child welfare context, how do those people feel about the deployment of such systems? What are the primary sources of discomfort in these communities surrounding the development and deployment of such tools? And lastly, what can we as researchers or designers or developers, what can we do in the development, design, and deployment stages to improve comfort among affected communities? And when we were thinking about these questions, we tried to examine them in connection to two concepts that are more common to the analysis of corporate operations rather than government operations. So namely, these are the ideas of social license and organizational justice. Social license is not necessarily a popular term, but we thought it was a useful lens in our context. It refers to roughly community and stakeholder acceptance of a company's operating procedures and business practices. And this can be compared to what some people rightly point to, which is the need for stricter regulations. However, what we contend is that algorithmic systems that are deployed in full compliance with governing regulation and governing laws may nevertheless fail to achieve license to operate. They may fail to achieve community acceptance. And we believe that this community acceptance is important because as someone who works on developing these sorts of tools, and I have answered in the affirmative the question, should we build it, at least sometimes. The potential that these algorithmic systems are viewed to have in promoting positive social change may fail to be fully realized because these systems will be met with opposition and sometimes not entirely justifiably so. So we want to build trustworthy systems, but then there's a question of how do we actually get people to trust them, and also what does trustworthiness mean in the first place? And in the context of organizational justice, what we thought about were elements such as procedural, interpersonal, and informational justice. These turned out to be very important when we were looking at the results of our workshops. So procedural justice, for those of you who are not familiar with this idea, it's a really important concept, especially in this context, because it's one element that's been found to mitigate the relationship between outcome favorability and support or acceptance of decision. So this has been studied in the employment and promotion context, that even if you yourself were not selected for promotion, if you believe that the process is procedurally just, you may nevertheless be accepting of that outcome. Right? So this refers to roughly the perceived accuracy, meritocracy, fairness, and ethics associated to decision. Another element that turns out to be quite important is interpersonal or interactional justice, which is, for instance, how information is delivered to you, whether you're actually treated by individuals in this process with dignity and respect. And these are perhaps not elements that we think about as we're designing algorithms, but as I'll indicate later, these are really important things that we can actually affect in the design process. Right? So how do we do this? Well, we adopted a participatory design framework, and this workshopping approach is just a subcomponent of that. And participatory design is basically this approach to try to incorporate the individuals who are going to be most affected by the system into the role of designing it. So make sure that their opinions and beliefs are heard up front. What we basically did was the following. We were talking to, I'll describe the participant group in a minute, but we were talking to individuals where we could not really assume a level of technical sophistication or a level of numeracy. So what we did was we adopted this comfort board, which was previously used by our design collaborators when studying the idea of data ethics and data sharing. And there are two axes here, which are not formally defined. So we think of these as kind of common sense ideas. One of them is the perceived benefit, where the further out you are on the x-axis, the higher the perceived benefit is. And the other axis is trust. Right? So the higher you are on the vertical axis, the higher your level of trust is. So what do these roughly correspond to? We're going to walk, or we did walk, the participants through various scenarios. Benefit is kind of the perceived benefit that they believe could result from the action taken. And trust is kind of how much trust they actually have, either in the system or the actors, that the system is kind of operating well, that this isn't a gotcha moment, things along those lines. Right? These were not formally defined. What we did try to articulate is that roughly the diagonal corresponds to a level of comfort. Again, qualitatively defined. We didn't try to precisely say what comfort means. But individuals who are very low on the trust and benefit scale would be said to have be very uncomfortable. Individuals who are up here in the light area are more comfortable with the decision. Our study consisted of 5 workshops in a single US county. And in total, we engaged with 83 participants, which consisted of families. These are the individuals who you might think of if I told you that I was to run a study with affected communities in the child welfare system. Okay, so these are actually families who have had encounters with the child welfare system. But we also considered 2 groups who are frontline providers and specialists. These are individuals who actually work in the child welfare system. The distinction between them is that frontline providers are individuals who actually engage with families. So these may be, for instance, caseworkers, service providers, people who actually go out and speak to families. Specialists are the people who are more likely to be using the tool. So these are the people who, for instance, sit in call centers, who make administrative decisions. They understand the details of cases, but they're not the ones who are actually going out and having interactions with the families. Right? So one thing I'll point out, because I think it's quite important in these contexts, in order to get families to provide us with what we felt like was free-form feedback, we ensured that peer support people were present at the family workshops. So peer support people, for those of you who are not familiar with this, they're quite commonly used in child welfare and also, for instance, in rehabilitation. These are individuals who have previously gone through the system. They have experience with this, and they may provide comfort and support in these kind of difficult situations where there might, for instance, be an imbalance in authority or perceived distrust with the facilitators of these workshops. The other thing is that most of the frontline providers and most of the family participants were women. This reflects the disproportionality of kind of employment and gender in these contexts. And one of the workshops actually specifically focused on participants identifying as persons of color. And while prior studies, and I think prior studies that have been mentioned in this workshop, have found significant differences in perceptions of especially procedural justice across racial and ethnic groups, we didn't actually notice all that much of a difference. Right? So there was a difference in terms of when participants self-described their experiences, and when those experiences were self-described as being based on being a person of color caught up in the system. However, while there may have been differences in degree, many of the general concerns that were articulated and the sort of information that was being requested was actually consistent overall. But one thing I'll get back to later is that, again, this does not mean that your race does not matter in the system, or your perception will be the same regardless, because we did not measure degree, and when we get to talking about solutions, it's not entirely clear that the same solution is going to be kind of a one-size-fits-all. So in order to actually be able to elicit some meaningful feedback about comfort levels with the use of algorithms, what we did was we developed a series of fictional scenarios. There are actually 6 of them, though D contains 2 sub-scenarios. And we called this Nicole's story. So we asked participants to imagine that they are the parent of a young girl named Nicole, and we facilitated a series of fictional events that unfold as Nicole grows up. So initially she's a child, and her mother gets caught up in the child welfare system because Nicole ran out of the house. And eventually it goes to Nicole having a child herself at the age of 16, and so on and so forth. So the way that we developed these scenarios is that we started with something that would be most proximate to the participant's experience. And we evolved it into a scenario where we had basically fully algorithmic decision-making using a huge amount of data, casting a very wide net, and roping and providing information to individuals who typically would not have it. And in developing these scenarios, the entire research team was involved in that process, but what we realized is that some of the knobs that we wanted to tune and some of the things we wanted to investigate just would not come across to the audience. So we had a prototyping session to make sure that at least we could study a smaller subset of elements, but in a way that was understandable, so we get meaningful feedback perhaps on a more restricted set of components. What are the sorts of knobs that we tuned? So we tuned whether the decision was proactive or reactive. A reactive decision would be, for instance, a call comes into the child abuse hotline and the system needs to react, right? And there may be an algorithm involved in providing like a risk score, just as in criminal justice, to support that decision. Then we toggled whether it was human decision-making, algorithm-assisted decision-making, or entirely algorithmic decision-making. So was there a human in the loop? Was there an algorithm in the loop? And the last thing that we toggled is the sort of data that was used. So was it child welfare specific data? Did this data also include criminal justice information? Was the information that was used potentially community data? So something that was not actually specific to the individual, but broadly obtained from the community where they reside. So those are the scenarios. So these workshops were facilitated. And in scenario 1A, we basically had individuals position themselves on a comfort board. This was just a basic, again, scenarios I described, where a child ran away from home, was later found, and this roped the mother into the child welfare system. And later on, instead of having people positioned on this large board, we positioned them on this smaller board with their anonymized name pieces. And the sort of analysis that we're able to perform on the basis of this data looks kind of like this. So this is a comfort board broken down by families, frontline providers, and specialists. The darker colors indicate places where there were more individuals positioned on that cell. Right? So this is for one of the scenarios. And we see here that there is, the sample sizes are really small. Don't read too much into this. But we see in general that overall we have pretty low or moderate comfort expressed with whatever the scenario was. This is 1C. And that's actually the trend overall. We saw very few cases where there was a very high comfort in the decisions, but I'll point one out later on. And what we tried to do, there's an executive report that actually came along with the research activities. What we tried to do is actually give voice to the individuals who participated in our workshops. So a lot of the report isn't kind of us speaking. A lot of the academic paper is us talking about the findings. But a lot of the report is actually quotations from the participants that are kind of reflective of the broader feedback that we received. And it's quite interesting. So there is a fair bit of variation across families. But one of the things that we'll see over and over and over again, so variation across participants, one of the things that we'll see over and over and over again is what's articulated in that first family bubble, which is this idea of complete distrust in the system. I can't have any faith in the data because I don't have any faith in the justice system. Right? So this is pertaining to a case where we said that we would use criminal justice data. Well, similar issues with just being in this child welfare system altogether. I think it was Nancy Krieger yesterday who pointed out that mistrust is actually not an issue with the individual. This is something for which the system is typically to blame, and that's something that we see over and over and over again. That it's not the algorithms, or it's not solely the algorithms, it's generally the system. So what are some of the concerns that arose through this sort of study? So first of all, system-level concerns were by far the most common reasons for low comfort in both algorithm-assisted and algorithmic decision-making. And this is because the concerns that individuals had about the child welfare system, which come from their prior experiences in the system and the biases that they've experienced, were readily projected onto any kind of use or submodule within this system. That if you don't trust the system in which this algorithm operates, you're not going to trust the algorithm. And this has been articulated in various ways across the groups. So for instance, this idea of investigation is in some sense already skewed. It's always been me against the system. It feels like a deficit model. Let's weigh up all the dirty things in your life and nothing good. Like this is everything we've seen before, right? What's new about the algorithm? I already distrust the system. The groups also raised significant concerns, it's relevant to this workshop, about the potential bias on the part of caseworkers in the decision process, and also bias in the data or the algorithm. So a lot of the individuals, both white and black, we're operating in a county where there isn't a very large Hispanic population, so the study really did focus on white and black participants. So for instance, families articulated that the system here in America just lets us down, especially if you're black. Someone said, how honest are we allowed to be? Most of our systems were not made for people of color, by people of color, or have people of color in them. Right? And then this latter point is actually quite interesting, and it pertains to the sort of data that's actually contained in administrative records, and I think it's highly incisive. And what this person is basically saying is that if you have if you're in a wealthy neighborhood and you have access to private health care and private rehabilitation services or just privacy in general, your substance abuse issues or your mental health issues, these are not going to show up on our administrative records. So the individuals on whom we will have the greatest data resolution are necessarily going to be the ones that already have prior public welfare engagement and perhaps already have prior distrust in the system. There were many concerns about whether a statistical model could account for context. Right? That we need a more humans in the loop approach. Right? How do these systems, how does the incorporation of algorithmic systems actually impact the interpersonal relationships? Again, this quote from the family, a computer cannot understand context, perhaps. Okay, most logistic regressions don't understand context, that's for sure. My son has autism, how does the data account for this? Right? So when we say that, well, if you have a human in the loop, this will decrease accuracy. Well, for whom, right? And what are we missing if we completely remove the people from the decision-making process, right? Accuracy on a single metric isn't necessarily the name of the game. Participants certainly wanted more transparency or information on how the algorithm weighs different factors and abilities to dispute the score. So Deirdre Mulligan gave a fantastic keynote, I think she's in here somewhere, at the Fat Star conference recently that talked about contestability. This is really important. It's not just a concern that's articulated at kind of the legal levels. This is a concern indicated by affected communities. And lastly, there were lots of concerns about how and whether risk information was communicated to families and caseworkers. So in particular, even clearly beneficial decisions where everyone agreed, yes, I can see the benefit here, those efforts were undermined by the fact that there was a mention of a statistical model in the first place and the way that it was mentioned. So let me just conclude on this last point, which is what can researchers and designers do in the development and deployment stages to raise comfort levels? Right? And this is based on kind of the discussions that we had following the individual kind of placements on the board and also the synthesize attempts at the end. Right? So each of these workshops lasted for a few hours. Right? There was lots of discussion about like why is your comfort level here? What can we do to improve it? What can you envision about the system? And let me tell you one thing, which is that just disclosure and numbers dumps is not going to actually solve the problem. Right? In particular, the more precise information that we provided in the one scenario where we had the opportunity to think about this, the less trust there was in the system. So what do I mean by this? Here's a scenario where we had a proactive model. So this is an at-birth model that flagged Nicole, now 16, who just had a baby, as potentially high risk and offered her voluntary beneficial services, but said that she was identified as high risk on the basis of the statistical model. Right. This is the comfort board. So specialists viewed this as being a decision they're very comfortable with, whereas families and individuals who work with families did not entirely agree. So these are the people who are getting the information about the tool, and these are the individuals who are kind of most directly affected by it. When we provided more information, so we actually said kind of how accurate the tool was, the more accurate the tool was in assessing risk. So it went from 1 in 5 mothers identified as needing support go on to have bad outcomes, to 4 out of 5 mothers identified as needing support go on to have bad outcomes if they don't get services. Trust actually dropped along the way, right? So kind of the better the tool is, the worse the trust level became. And why is that? It's because there's an issue in communication. You can't just say a statistical model, present numbers that might convince people in this room, and expect that to be good. So let me just conclude with this slide. So what we concluded in this study is that effective decision strategies really need to consider how technological solutions can be designed to work in concert with complementary policy changes to impact community perceptions of system justice. Right? So it is not going to be enough to introduce transparency or explainability or do a numbers dump or produce the regression model. All these things are things that we can do. We as designers are completely willing to. But there's an issue with how, for instance, interpersonal relations are actually affected. Whether I present you information on the last time that you relapsed or how long you've been clean, whether this is positive or negative information, this anchors individuals in different ways, and it affects the interpersonal interactions that people have. And fundamentally, the way that the system is governed right now, those interpersonal relationships are really the basis upon which everything rests. And if we cannot promote trust at that level, then there's very little that we're going to be able to do to move the needle with technological solutions. Right, thank you.
Why don't you go ahead and answer a question while Zach is setting up? Because I see that Katrina has a question.
Alex, thanks for this really important and interesting work. Can I offer maybe a slightly different interpretation of this change you presented at the end? Whereas the tool became more accurate, people were less trusting of it. I was wondering if an accurate tool that says there's a high chance we're going to take your kids from you makes people feel that the system is against them.
Yeah, no, that is entirely the interpretation.
Okay.
But I don't think that's what we think of.
Right.
When I tell you my tool has higher positive predictive values than your tool, you might view that as a research threat, but you would agree that my tool is the one that should be deployed, right? So this is where I think what we jump to as our table of numbers isn't what the community needs, even though this sort of disclosure may be important at other levels. But you're absolutely right, that's exactly what's going on.
Thanks. Okay, the next speaker is Zach Lipton from Computer Science Department at CMU.
Hi, everyone. First, thanks to the organizers for having me here. This has been a really interesting session in that I think a lot of us, I guess from the computer science side, have had dealt with these issues in a way that crosses from maybe the technical into the interdisciplinary, but not crossed completely over into the other disciplines. And so we talk about race and technical systems in the context of technical systems, but not necessarily seeing how these concepts are dealt with outside of the context of technical systems. And in particular, I'd like to build on a couple main points that come up over the last day and a half. One kind of recurring theme yesterday was this sort of peril of having problematic definitions and concepts, and race itself being that problematic concept. And maybe what would be a bit different here is there we're in a situation of inheriting a flawed concept and being stuck in a world that has an entire literature and academic culture that is built around this flawed concept and figuring out what to do with it. And perhaps in the context of some of the modern discussion on fairness and interpretability, we're in danger of creating the flawed concepts ourselves, of misrepresenting what we're doing or what problems we are solving by attaching names that don't maybe accurately describe what we're doing. There's also another point that I'll be maybe building on that came up in a lot of other talks from the other side, which is this idea of outsourcing these social problems to technocrats. And the danger that what we end up doing is creating a sort of reductive formulation of a lot of these problems where we can sort of purport to solve them. But what we've solved is our sort of, like, all of the important things have fallen in the cracks between the sort of reductive definitions we can come up with and the actual underlying problems we're purporting to solve. So I'll try to go through my slides relatively quickly. I have a couple more slides and I have minutes, so I'll have to move fast and maybe skip over a few things. But sort of I'll try to take on from two examples in the context of both fairness and interpretability. So in general, I just want to clarify that here we have a diverse community that's talking about these issues in the context of various technical systems, not all machine learning systems, some in the context of genetic testing. In particular, my lens, just given that it's the only thing where I have some modicum of expertise, the lens that I approach these issues from is the use of machine learning, being a machine learning practitioner and scientist. And in particular, while there's a lot of research on a lot of different types of supervised learning, nearly all these sort of operationalized systems in the world that we are actually talking about usually in some form or another supervised learning systems. So there are cases where we don't know how to program a computer to do precisely what we want it to do just by writing a set of rules. But we do have access to some data set of, given some inputs, what is the corresponding output that we might like to see. We feed it into some algorithm that spits out a model, and this model now we can feed through a data that we've never seen before, and we hope that the answer will look like something like the outputs that we would have liked to see if we were manually annotating them. Neural networks sort of get thrown around, I think, perhaps in a misleading way here. Neural networks are just one among many classes of models that are used to solve these kinds of approximation problems and to extract patterns. And there's many other tools, and I think sometimes, maybe because they are new, a lot of times problems that are maybe like universal problems are being cast as problems of neural networks, or maybe were actually they're problems of the paradigm entirely. Deep learning, which is a term that gets thrown around a lot, just means big neural networks. And it's important to note that while we have a tendency as a society, and I think we're guilty of this often as practitioners in this field, of assigning all kinds of sort of like anthropomorphic qualities to what's going on in machine learning, like basically all we're talking about is curve fitting systems. Right? We stick in some data. We try to approximate some outputs given some inputs. That's it. There's a nice sort of critique of how we've sort of settled from this by Yuda Pearl, who's been on the, I guess he's been on the war path on social media and various other media. This is an article in The Atlantic where he kind of makes his stand against maybe our myopic vision in curve-fitting land. So, I think a big problem here is that fundamentally we're often just doing the wrong thing. And the entire casting of the problem, right, is wrong. Like, we are applying supervised learning in general. Like, what supervised learning is good at is given data offline from some distribution, where some patterns hold in it, we can extract some pattern, which would hold if we saw data that came from the exact same distribution that generated the data on which we trained. And this is just fundamentally not what we're actually, there's a fundamental sort of problem mismatch with almost everything that we actually use machine learning for. Like, that's not in and of itself useful. What's actually useful to a business is like making a decision. And so almost always we're actually concerned with making a decision, usually with some kind of intervention. There are cases, I think, where there's not really a closed loop where what we're doing is so close to a pure super. If we're doing pathology and we're trying to recognize does someone have or not have intestinal parasites based on a microscope image, we're doing. It's unlikely that correctly identifying intestinal parasites is going to change what images look like in the future. And so, it's okay. We get away with the fact that there's maybe the data distribution is changing a little bit over time. There's subtle violations of the machine learning contract, but they're not so severe. But in general, when it comes to like businesses, recommender systems, we're just doing something fundamentally wrong. We're participating in a system of incentives. The way we make decisions influences the behavior of the people who are interacting with the systems. I think recidivism, which has come up many times here, is a clear case of just we're fundamentally addressing, putting someone in jail as a punishment. It's like if I punch someone in the face, I would increase the risk that they would commit a crime themselves in the next few days, and yet they shouldn't be punished on account of me punching them in the face, right? But we're sort of mistaking what is like there's something fundamentally philosophically wrong often with what we're addressing is just not a prediction problem. We want some kind of intervention, and that's not really what we're dealing with. So there's all kinds of mismatches between whatever our real-world desiderata is and what is provided by supervised learning. On the other hand, supervised learning sort of works in the sense that you can build operational systems that provide some kind of economic value. So we overlook this. We overlook the fact that we're addressing the wrong task. We're calling something a prediction problem that's not a prediction problem. We're inserting it in the world in a way that distorts behavior and changes the distribution. And so we have a growing literature now on sort of the CATS problem different ways. One looks at sort of disparities that emerge from the use of these problems and say we need to somehow correct the algorithms to make them fair. Others that say, the problem is actually the inscrutability of the models, that you can't look inside the model. So people are saying that actually what we just need is to make the models interpretable. And if you make them interpretable, then these problems go away. And the real danger is, if we cast these problems the wrong way, we run a risk of actually being like bad actors in the fight that I think we're trying to be on the right side of, because there's a big danger that what we end up doing is actually giving, and I think this point's been made more articulately in the previous talks. Particularly I think Jonathan Ruha spoke, about this danger that we will sort of like the outsourcing of judgment to sort of technocrats. I think we run the risk of giving the purported tools that are sort of a claim to solve these problems. And here's an example. I made an editorial decision to censor the tweeter, so I can report only the tweet, and everyone is bound by honor not to Google it, so I don't feel bad. I think this kind of thing is real dangerous. So this is someone, I guess I could plagiarize a Sendil or something. This is, I won't say where this person works, but it rhymes with Google. Someone who's sort of accused, and actually the thread is kind of loony, because if the person on the other side of a thread is like a sort of, someone who writes 9,000 tweets or whatever, somehow he got engaged this prominent machine learning researcher who sort of responds to accusations that they're doing bad things and says, well, look, there's many papers, including from my group, like we're making progress on this. And I think there's a big danger that it's become sort of cover, like if you look at the functional role that we're playing in a lot of companies, it's that they can say, hey, no, we take these issues seriously, we have a team that works on it. And the danger is that if what we're providing is not actually solving the problem, even if our intentions are good, we can end up sort of giving someone the algorithmic fix. So it allows someone to continue doing qualitatively exactly what they're doing, but to attach prefix fair in front of it. And then we sort of become complicit, I think, likely unwittingly. I think people don't mean badly. So on the first side, right, so I think you've heard about all the ways that sort of algorithms can be biased, in particular in the context of supervised learning. Right, there's many things that, what we mean by bias, there's many sort of failure modes that we sort of lump together under this term. Some things are when groups are underrepresented. Some issues are when labels themselves might be themselves fundamentally have errors that are actually biased, right? Like if you have something that is a weak surrogate for some notion of employee quality, but the employee quality is the judgment of existing managers, and they themselves, like it could actually be truly biased, like in a statistical sense. We could just be optimizing models fundamentally for the wrong task altogether. We could even have the problem that like the task may not be equally easy for both groups. So Jan LeCun made this point on a panel that we were on recently. He said, someone talked about the underrepresentation of people in face recognition data sets. He made the point that even if you equally represented people, you suffer the problem that there's already a certain kind of bias baked into the way that digital photography was designed in the first place in terms of the assignment of dynamic range to different parts of the color spectrum. And so that it's more difficult to recognize darker faces than lighter faces just because of how sort of photos render. Right, so, and these issues are complicated by the fact that in the data that we inherit, all of our features are related with each other. Protected features like demographic membership are associated with all of our covariates, are also associated with our labels of interest, and also subject to measurement error. So then on the other side, we say, well, what is the, I think as algorithms people, we end up looking to the law for some kind of inspiration of like, well, what are we supposed to do here? So people end up, at least, in a sort of US-centric kind of fairness literature, often turning to the notions of non-discrimination that emerged from Title VII of the Civil Rights Act of 1964, and in particular, concepts of disparate treatment and disparate impact. So the disparate treatment doctrine is, these are both complicated doctrines that have, like the main thing I want to articulate here, these are complicated doctrines that have aspects that are not captured in any current like machine learning treatment of these problems. Disparate treatment is concerned with decisions that are explicitly based on a protected characteristic, but it's a little bit more subtle than that. You are allowed to use protected characteristics in certain contexts, and it's not called disparate treatment if you are using a protected characteristic in the service of something like promoting diversity that is considered a state interest. There's a notion of intentionality associated here, which raises the question of the applicability of the law or how well it describes a technical system where perhaps nobody has any intention involved, and yet you can still have discrimination arise regardless. And you have a notion of disparate impact, which talks about an unjustified adverse impact on members of a protected class. And here, you look basically along some demographic, and it's actually a very complicated law. The first step is a plaintiff has to demonstrate that there's some kind of disparity. Then the defendant can come back and has to argue that the decisions are justified. And the plaintiff has to come back and now show that the defendant can achieve the goal, their business goal, with some kind of alternative practice that would have less disparity. And so all of the components of this, like justification, is not something that sort of is well articulated within the technical paradigm. And this third notion here of like an alternative practice sort of like speaks to a kind of counterfactual reasoning that the tools we have are not actually doing. So there's a whole literature on fair supervised learning that basically takes supervised learning and adds, in addition to features and targets, a sensitive feature. And some way or another says, let's try to output now a fair model. We say we have to make groups equal somehow, but the question is how. So there's a whole sort of catalog of ways that we try to make groups equal vis-a-vis the combination of the features and the protected attributes, and also the outputs of our model. We have a tendency, which I think is a very dangerous one in our community, to call these fairness definitions, which I think is problematic because they are not, none of them, we have, they say we have 9 million technical definitions of fairness. The truth is we have 0 technical definitions of fairness. We have many, various postulated, proposed statistical parities of interest that are somehow related to our interest in formalizing fairness, but do not in and of themselves, they don't possess the right ingredients. They're missing, put it this way, you can come up with any number of cases for any one of these definitions where it's either seems like a very fair thing to do to try to optimize this kind of parity, or it seems like the most unfair thing you possibly can do. And that difference depends upon quantities that are extra statistical quantities, right? Like the difference between why you should say that I should be concerned about outcome disparities between, say, black and white Americans vis-a-vis college entrances, but I should not necessarily be pushing for absolute uniformity between, say, white and Asian Americans, has to do with a knowledge that we have that isn't captured just in the formalism that says, I have covariates, sensitive covariates, and predictions. There's something else that's not captured there. So blindness is formalized saying, let's just not look at the sensitive feature. This sort of impact parity is what people do is they say, well, we're going to have this condition that has to hold that something is equal, and it's going to depend on the sensitive feature. And there's a whole set of algorithms that are proposed called disparate learning processes. I guess Alex and I called them disparate learning processes in a paper. This is joint work with Alex and Julian Macaulay, where basically people have proposed a whole bunch of algorithms that come up with ways of trying to say, let's not look at the sensitive feature because we think you're not supposed to do that because of a potentially wrong interpretation of what disparate treatment means in the law, as it's been formalizing it perhaps incorrectly in technical ways. And say we also don't want to have impact disparity, so we're going to try to sort of thread the needle and have a model that's accurate, subject to having impact parity without looking at the sensitive feature. And the problem with this is that, first of all, it's not clear that you're not actually allowed to look at the sensitive feature if the interest is for the sake of increasing diversity. So it's possible that the problem that we're trying to solve is itself contrived. And further, the problem is that it turns out actually looking at the feature, if your goal is to reconcile having an accurate model with having sort of demographic parity, looking at the feature is the optimal thing to do. And so if it turns out that your non-sensitive features actually encode the sensitive feature, that your model is going to end up doing functionally the identical thing that it's going to do. So we end up proposing a solution that is functionally identical to what you get from an unconstrained classifier, but we call it fair. And there's a big danger. On the other hand, if you can't fully recover, if you can't fully infer someone's race or someone's gender from the non-sensitive features, then you end up having all kinds of bizarre side effects. One of them is that basically the model just looks for proxies. And so we end up coming up with a model that's explicitly doing this sort of like most procedurally like unfair thing, which is that it's rather than just saying explicitly we want to equalize things, we end up creating a model that is tries to achieve the equalization on the basis of proxy variables. So in this like synthetic example, we have a model that tries to use hair length when it's not allowed to use, say, gender. And in a real example with master's admissions decisions, what we actually find is that so if you take a model and you try to predict with the same model class, is someone female or not? This is admissions to masters in CS. You get some scatter, and if you also try to train the model, which is presumably what you would do if you were just using machine learning to guide admissions, predict admissions outcomes. You predict whether or not someone will get admitted, you predict whether or not someone's female, and then you apply one of these fair classifiers off the shelf. What it ends up doing is it helps a lot of men, it hurts a lot more men, and then it makes so most of the decisions that get flipped are actually men who get flipped to negative and men who get flipped to positive. And then there's a smaller number of flips among women, but what ends up happening is basically the women who the model thinks are more likely to be men are hurt by the classifier, and the women who it thinks are more likely to be women do benefit if they're just a little bit below the acceptance threshold. But the dangerous thing is you look into it and say, so what is it that makes someone likely to be male? And it turns out to be things like what they want to study or who they want to study with or which group they want to be part of. So you end up, by neglecting the fact that like we're participating in a system of incentives, we create the system that is actually in a way like a reinforcement of stereotypes. It basically says, hey, if you're a woman and you want to benefit from this policy that is trying to increase the number of women, then you have to say that you want to work in HCI, not in theory, because it just so happens that there are more women who apply in the historical data to that group versus the other group. And so, if we don't look at these things, if we just look at, in a very kind of naive way, we run a big risk. Just, I guess, very quickly, what I'll just touch on is that, a whole bunch of other people are attributing the problem, saying, actually, you have a lot of papers that say, hey, machine learning is used in all these critical ideas, in all these critical settings. That's very dangerous. And the models, we don't know what they're doing. If only we could look inside the model, then these problems go away. The problem, so presumably there's something about, the model itself. It's that the inscrutability of the model is somehow at the core of this problem. And that if there was only something we could extract from the model besides its prediction, somehow this is going to solve everything. The problem here is that basically these papers sort of make this leap from that to just proposing a solution and then generating some kind of figure and saying, look, our model's interpretable. But what's never actually articulated is what is interpretability in the first place and how does it address any of these fundamental underlying problems. And basically what I went is, at some point, and I guess I don't have that much time, so you can go, I guess, read the paper. But fundamentally, the problem with interpretability is that it sort of ends up being a wastebasket taxon. So does anyone here know what an antelope is? Sure. So you think you know what an antelope is, maybe, but it's, an antelope is not it's not a coherent categorization of animals. There is no species called antelope, right? It's like all the horned animals that kind of look like a deer that we don't have like a stronger affinity for, haven't bothered to give it a name for. We call them antelopes. And so a lot of them are more related to a water buffalo, or more related to a deer, or more related to something else. So what we've done is we've sort of created sort of the wrong, I think, taxonomy. If you actually read through the papers, which is I tried to figure out, what is it that these definitions have in common, or what is it that interpretability truly is, it's this weird mixture of people sort of talking about out-of-domain robustness without actually really dealing with it, or sort of punting to a similarly murky concept, which is trust, without really saying what is it that should make a model trustworthy, or sort of opining in the introduction about causality without actually doing any work that fundamentally addresses problems of drawing correct causal inferences. And so you have this whole literature that consists of on one hand, different ways of saying that models should be simple or have, interpretable coefficients without actually doing it, or models that consist of like squinting at a learned model and trying to draw some kind of qualitative insight by, poking at the neurons or generating some visualization without actually any kind of coherent technical definition that says, what precisely.
To be fair, this might be inherited from the way people talk about neural networks totally independently of fairness.
Sure. I think the danger is that, if your goal is just classify accurately and you speak in a kind of sloppy way, but the community at the end of the day produces strong results on holdout data that hold up, you're sort of can be forgiven. Whereas, if you're ultimately saying this is my certificate, this is why you should feel now comfortable using machine learning in a critical social setting where otherwise you wouldn't, just on account of this, the end product is the interpretation, and not like some hand-wavy nonsense that happens in the telling of the paper along the way. It's a very different kind of setting. Anyway, I'm over my time, so I'm happy to chat offline some more. But I think it's important to be really careful. I think we're at a point where we are in danger of being part of the problem. And I think when when people are creating legislation now, like in the GDPR, saying that like, okay, algorithms have to be interpretable, and we come and say, I've got the interpretable algorithm, like, there's a strong career incentive to do it, to say, we propose an algorithm and it is interpretable, and see, the GDPR is asking for this. But, there's something fundamentally, like, ethically wrong with it if what we're not actually providing, is something that should give succor to anyone who is subject to these sorts of decisions. We shouldn't claim as motivation a problem that we're not actually addressing.
So, Zach, could you just say a couple words about the breadth of audience that would be able to benefit from the mythos of model interpretability? I mean, you don't have to be a super expert, so say something about that.
Oh, I don't think there's, I don't think I ever entered math mode in writing that paper. So, and I wrote that paper in maybe my second year of PhD, and I had been a musician up until I started PhD, so I don't think I knew any mathematics at the time. And that's, I think, basically, if you have ever played an instrument or not, then you are able to derive as much from it as anyone else.
Next speaker is Martha Minow from Harvard Law School.
Thank you, and I give my thanks also to the organizers and to everybody who's participating. This has been extraordinary. The assignment of our panel is governance, and I think we've had already really interesting discussions about participation and about mismatch of the actual application of...
For 1 minute, we can't really hear you.
Hello? Is that better? Yeah? I just think that so far in a panel on governance, we've already had some great discussions about the role of participation and perception, and also about kind of fundamental mismatch of applications of certain kinds of technologies to certain kinds of problems. I'm going to step back and just talk a bit about what is governance and what's the map of governance options. And as I do so, let me just say I Googled, because why not, data governance, and out came a lot of cartoons, none of which were funny. I mean, truly. I mean, I suppose one that was sort of funny was someone saying, well, we usually mean something better than it because I said so. I don't know. But based on the conversation so far, I'm thinking maybe we could do better on what a data governance joke would be. It could be a group of people saying we're working on it. I'm not sure. But so what is governance? Governance in general, it means the elements a society uses to harness resources and organize individuals in groups. And good governance in a liberal democracy is usually defined as having 7 dimensions: participatory, responsive, effective, efficient, equitable, inclusive, and following the rule of law. Now, I think a lot of the problems that we are here assembled to talk about are that most people who are not computer science people don't think that having an algorithm making decisions in your life is participatory, responsive, equitable, inclusive, or following the rule of law. Whether it's efficient and whether it's effective, I think that those 2 terms are closer. And accuracy is, of course, a dimension of fairness. But just take as an example the preamble to the South African Constitution enacted after the transition from apartheid. And here I'm thinking a bit about Ruha's point about maybe we could do something better than neutrality. The preamble to the Constitution for South Africa says that this constitution of governance is organized to try to undo injustice. It's not a neutral activity. It's an effort to try to produce a change in a society that has been unjust. And I guess I want to have that inform my discussion, but here's a map. Yesterday's discussion seemed to raise just some examples of questions that would be thrown into the governance world. Who will say that the data in a medical library, this is Evelyn's discussion, should be cabined or tagged for defective racial terms and concepts? Another governance question: how to restrict the migration of polygenetic risk scores or face recognition or 23andMe data or any other technology from the intended use to something else where it's not appropriate? Or how do we build equivalent or better oversight and infrastructure that's like bioethics as it has developed in the medical context for the world of CS and machine learning and AI? Can we do something better? At the moment, we don't even have that. And would it be led by CS people? Would there be a peer review or certification process? Would there be participation by affected publics, as Alex was describing? And another example of a governance question is who will define good science? And can we do that while defending science in a time when science itself may be in jeopardy? Those are the kinds of questions. So governance always exists. The question is what kinds? And there are 4 basic kinds that I think surround us in this world, in this time. Markets, with corporate boards being an example of how markets are not natural or neutral. They are actually constructed and designed by law with lots of organizational, institutional apparati. Laws and regulation, more generally. But governance also includes norms and ethics and peers. Peer pressure is maybe one of the most effective forms of governance, but also peer networks. And then there are technical forms of governance: code, data governance, algorithmic standards, a smart contract that's enforceable the minute the last character is imposed. There are disappointments and lessons from past efforts to have governance. This is generic, although some already are familiar in the world of algorithmic governance. There's short-term profit orientation. And that's true of markets, but it's also true of personal ambition. I think as Zach was describing about career ambitions of people who want to make their career around saying that their algorithm is transparent. There's regulatory capture. We create an oversight body that ends up serving the interests that it was supposed to be safeguarding. There's political retrenchment, undoing regulation, like what happened with 23andMe and the Food and Drug Administration. There's a focus on individualism, like informed consent or privacy and bias, when in fact there's systemic problems. There's political and intellectual weakness of alternatives to a kind of libertarianism. The default position that's dominant in the United States for the last 40 years is there should not be regulation, that the market is the answer. It's better to break things and ask for forgiveness than to ask for permission, and no one is more competent than us. There's technical world siloed from consequences, again backed by economic incentives that make improvements difficult. And there's a weakness of norms and relying on norms, which I think many of us are coming to an awareness in our current world, where politicians violate what everyone thought were norms and nobody cares. So who are the stakeholders for governance? This is kind of obvious, but I just thought it was important to name them. They're patients and consumers and voters and students, as an example. There's the for-profit sector. There are professionals and academics. There are formal governments at many, many levels. There are informal governance organizations, nonprofit organizations, non-governmental entities, domestic and international, and they're standard-setting bodies and networks. They're challenges for governance. And these are challenges that I think are particularly persistent and visible in the world of algorithms. Justifying regulations against the background of libertarianism, I've already described, but also a kind of technological progress, a kind of inevitability. And a market is efficient, and we can just trust the progress. There are competing priorities for attention. There are a lot of things that people care about right now beyond algorithmic governance, like, kids at the border. And it's great to see a piece of legislation introduced by Cory Booker in the Senate. It's not going to get enacted. It's not going to have a hearing. Okay, so that's a big problem right now. There are competing goals and trade-offs, even if there was attention to something like that bill. Speed versus accuracy, distributional concerns versus private property protections. And we don't actually have good ways to resolve these fundamental differences in goals. There's a time and an expertise gap here, particularly I think a lot about how technology moves faster than any regulatory system can, and how the ability of any government to hire the talent to keep up with what's going on in the private sector or the academy, it's not possible. There's coordination and preemption problems, as the US basically has failed to do much here. Well, so Europe is the leader, but it's not just Europe. We have on issues, for example, of regulation of hate on the internet. We have now competing regulations, Singapore, UK, as well as the EU, and then which system runs? There may be a race to the bottom. That means the lowest form, the worst form of regulation, or a race to the top. There's competition among jurisdictions, and then unanticipated consequences. I will cede my time for our collective discussion, but particularly to Pat, but just want to close by saying we can talk about governance, but I think that what's most exciting to me about this gathering is the possibility of a movement, which is different than governance. A movement is about this idea of change, that where we are is not adequate, and even just borrowing existing governance techniques from other fields is not adequate, because we're dealing with the background of all kinds of injustice, particularly racial and economic injustice in this country, but in the world as well. And the possibilities then of movement activities that link together people who are experts, people who are students, people who want to put their different fields of knowledge together. I love Ruha's point about the arts. I teach a course called Law and Social Change, and it has been very striking to me, looking at the history of different movements, how critical the arts have been, whether it's music or visuals, for the imagination, parody, big one, narrative, coming up with a story where you can imagine a different future. science fiction, and also better cartoons. Thank you.